Okay, so this is Psych 3280, week 9, your basis of consciousness. And this week we are going to talk about the dissociation of consciousness and attention. Okay, so before starting, let's recap what we talked in week 8. First, I introduced different aspects of attention through different kinds of the definition of attention. And in particular, I pointed out important distinctions of attention, such as bottom-up stimulus-driven component, and also top-down volitional goal-direct component of attention. And then for each of them, we can have different types of the attention based on the space or time or feature or object. And these are all operating potentially by the different thing, dependent on the different types of the neural mechanisms. And then we discussed different ways to manipulate attention. And these are the 4 paradigms, especially useful for the discussion of consciousness and attention, change and inattentional blindness, and also attentional blink and the dual task, as I showed the demonstration. And also, I talked about the neural mechanism of attention using a biased competition model, basically meaning that each of the neurons have a different receptive field and higher level visual area have a potentially conflicting information from subsets of the neurons. And biasing signal can make one dominate over the other, like a winner-take-all kind of situation, so that the higher level neurons can potentially be responding as if that particular neuron is seeing only part of it and ignoring the other. And I also said that the source of the bias could be is likely to be frontal and also parietal areas. And I discussed Thierry Moore's work on the microstimulation of frontal eye field while recording B4 neurons with overlapping receptive field. And then based on these 2 types of the neural mechanism of attention, just simply try to see whether it's possible to explain some of the attention-related blindness. And for example, these 2 types of the neural mechanism says both inhibition and also amplification of a signal with respect to the current behavioral goal. And that could be largely explained, the effects in the change blindness or inattention blindness, as I discussed. And then towards the end, I also introduced one model or theory of consciousness, explaining these attentional-related blindness, global neural workspace theory. We didn't go into the detail of the theory, but potentially we will talk about it in the next weeks. And then the global workspace theory also introduced this 2x2 taxonomy of how the strengths of the top-down top-down attentional amplification and the strengths of the bottom-up stimulus result in different types of the conscious experience. Essentially, GNW says that the top-down attentional amplification is necessary for the conscious experience or conscious report. And then in this week 2, what we are going to do is to review the evidence for the different types of the dissociations between consciousness and attention. And in particular, we also discussed that whether we can pay attention to objects that we do not consciously experience. This may be a bit strange to you, but we'll see how the evidence is going to turn out. I also will discuss whether we can consciously experience something without paying attention to it. And this is also another strange kind of concept potentially for you. And we'll discuss the detail of these lines of experiment. So the learning objective of this week is to understand what are the logic and evidence of experiments which demonstrate dissociation between attention and consciousness. How do they manipulate and assess consciousness? And this is important to understand, and this is a kind of the stuff that I'm going to mainly ask in this week's lecture quiz. Also, how do they manipulate and assess attention? This is another component that I'm going to assess in the quiz. And then this week, we will not require you to read any of the reading materials. And as I said from in the last week, we are now approaching to the sort of the forefront of the consciousness research. So I just upload 2 of my previous review papers, but they are potentially advanced kind of component, and you will not need to read these. Unless you are interested in this topic as a potential honors, student next year and so on. All the quiz materials can be answered if you understand the contents of this lecture. Okay. Let's start. So the starting point of our discussion about attention and consciousness is this diagram. And if you remember, this is a diagram explaining the blind side patients' behavior. Blind side paper we discussed a couple of weeks ago. So the upshot of that blind side study was that blind side subject who report not seeing the vision, however, can locate the stimulus or move eyes towards the stimulus, may be mediated by not the standard pathway such as this. This side, the right side, is a usual, healthy people's, brain's connection. Eye is located at the bottom, and then there are many branches of the subcortical pathway. And then here is a LGN, lateral geniculus nucleus, and then that projects to both V1 and V5. And then that's the sort of the standard kind of, cortical pathway, visual pathway to generate visual experience, presumably. On the other hand, the blind side patient has basically damage in the V1. So there is no V1, and that degrades the LGN retroactively. So we don't have much, input coming from eye to LGN to visual cortex. Instead, what is known is that the branch to go to superior colliculus and then pulvinar, that leads to these higher visual areas are still there or potentially enhanced. And these are potentially mediating all this behavior without giving rise to conscious experience. And then the one point that I need to point out here is that the superior colliculus, as well as pulvinar to some extent, is that this one is known to be involved in the attentional processing in many ways. So if you look at the superior colliculus and search for PubMed or Google Scholar, then you'll see that it is described as an area for attention, and attention in both in terms of the eye movements, overt attention, and covert shift of attention. So one possible logical, inference you can make is that maybe conscious experience is completely gone in this blind side people, but maybe attention is intact, or at least potential is still there. And that's the kind of the question that these researchers who studied this attention without consciousness started to pose. So one of the earliest type of this study, which asked, can attention affect on non-conscious processing, is Kentridge, Robert Kentridge, who is in the UK. And he has been publishing this line of the research for many years, roughly 20 years by now. And first, he has been studying the blind side patient, GY, for a long time. And then he combined the attention experiment on his, blind sides, a blind field. And this, as you can see here, this is already an experiment 2 of this particular paper. And the experiment one basically suggests that blind sight patients can direct attention to the invisible field. But experiment 2 is much more compelling, and that's why I'm going to discuss more. So here, what Kentridge did is first to present the cue for the attention. Okay, this 2 bars that looks like a bar here, but it's a low contrast or high contrast Gaussian line kind of thing. And then, by the way, the time goes from top to bottom. So the blind subject would, blind sight subject would be sitting in front of the display, and then there will be some kind of flash of the cue coming up, and then there will be a beep, auditory tone here. And then right after that, there will be either some kind of stimulus at the location that is cued by this cueing stimulus or somewhere else. Okay, and then this is a standard attentional task on its own, unless if you do it in a blind sight patient. So the way he did it is the following. So first, it is a cued detection task, and Kentridge gave an instruction to this GY blind sight patient. So in a way that so he already declared that target will be present only 50% of the trial. So that's indicated in the bottom of this figure here. Okay, 33% and 70% added up to 50%, and other 50% are absent. Okay, and however, we have the thing about this experiment, unlike the normal subject experiment, is that this target is going to be presented in his blind field. So he would be expected to not to see any of these targets. Okay, but he was told, GY was told that there will be a target 50% of the time, and he understands. Okay, yeah, I do this weird experiment, and then. Sorry, this is not an ROQ, but the Q, attentional Q, is valid in showing the location of this target, roughly at 67% of the time. But he also was told that Q will not be visible, so he may see it, but it's likely to be presented in the location of his blind field, so it's not going to be visible. By the way, his blind field locates roughly like something like this. So both target and Q is not going to be visible to him. Okay, and then he was told to press the button as fast as possible. So this is a reaction time experiment, and then every time he pressed the button to report either he saw it or not, he needs to tell to the experiment whether he saw either Q, he saw the target every trial, and then whether he saw the Q, attentional Q, in every block of the experiment. So that's the sort of the setup of this experiment. And here is the result, and this is a very complicated diagram, so I will go through one by one. So x-axis is first of all, it's a block number. One block is composed of 40 to 50 trials or something like that. And then y-axis is reaction time on this side, and then also it's a double y-axis. Correct discrimination is on this side. And then black and gray dot here, these are the reaction time measure. So what you can see here is that the invalid or valid trials make a difference in terms of reaction time. So the Q, when the Q is preceded at the location of the target, it's a valid trials, and the valid reaction time is faster. And the invalid trials that Q is presented on the opposite location of the actual target, it's longer. So that's a nice attentional kind of manipulation and assessment. And then in terms of this two white circle and the white square here, these are the awareness or consciousness measurement. And this refers to only this right side, these are on this y-axis, correct discrimination, meaning that it's roughly like 70% of the trials. The location, the report of the detection is 70% correct, regardless of the location of the cues. So just to recap, first of all, GY, the blind side subject, never reported in this particular experiment seeing the target on each trial. And also, he also denied seeing the cues on every block. After the every block, Kentridge made sure that, did you see anything like in a cue? And then he said, no, 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 okay? So in terms of consciousness, GY did not see both cue and also target. That's one point. Next point is that GY was always above chance around here, above chance in terms of 50% of chance is the, target detection. And he is roughly 70% correct in a localization of target, okay? So he was able to say that, detect the target localization, quite well above chance. And also importantly, there was no difference in terms of queuing. So here it is an sort of a replication of the standard blind side result. And then finally, important thing is this, reaction time was faster for the Q target. Okay, so this is the summary of the result per se. Let me unpack and recap this important result. Okay, first, GY, the blind side patient, denied seeing both attentional cues and targets for the detection. And what he said here is, quote, I just listen for the beep and press a button. So as I explained to you, the experiment goes like this. And remember, and also try to imagine what it's like to be in a GY situation. You don't see things on the top right field of the vision. And suddenly, something is flashed, which is Q, but you don't see it. And then you hear the auditory tone to say that, there will be some target happening in your, again, invisible field 50% of the time. And then you are shown this, invisible thing. And then because the auditory tone says that, I need to respond, okay, I say yes or no, I saw it, and then say that, it was in here or there, even though I don't see it at all as a blind, sight patient. But somehow they are just correct, which is very, very weird. And he knows that he's a blind sight patient and so on, but that's how he describes his experience. And then the detection performance itself is above chance and doesn't depend on the attention. So this part is a replication of the standard blind side behavior, okay? And then what's important for the attentional literature, attentional consciousness, is that the bottom-up attention was spatially withdrawn by the invisible cues to facilitate the processing of the stimulus to hasten the reaction time over there. So this is one of the first demonstration of attention without consciousness. Okay, so here is in a sense of the beginning of the literature trying to dissociate attention and the consciousness, and it was important. That's why I went into the detail. But one important question to stop here is that is this an isolated and strange finding confined in a blind side? And we are going to take a look at the evidence in the healthy subjects in the next.